We are asked to write the mechanism, the reaction mechanism for the following esterification reaction. We are going to show the step-by-step processes that happened that converted this methanoic acid to methyl methanoate with loss of water when it reacts with the ethanol. So I'm starting with this methanoic acid. Remember, this is acid catalyzed reaction. So this sulfuric acid, I will present it like this because it's going to donate one of its protons to this acid. Now, looking at this acid, the carbon here is more electronegative. These are the lone pairs already here. So the oxygen will attract the bond pair of electron to itself, creating a negative charge. This negative charge will now attract this acid, while one of its protons will lose the bond electron and become positive. When that happens, the oxygen will donate the electron, and we now have this. Now we bring in our methanol. We bring in the methanol CH3OH. What this methanol does is to protonate this particular species. To protonate it means that this hydrogen is going to leave this place because oxygen is more electronegative. The oxygen will attract the bonded electrons, and hydrogen as a proton requires this lone pair. The lone pair from the oxygen goes to this hydrogen, and we now have this. We now have this. H here, lone pair. That is what we have. And because hydrogen has come in here, it has created a partial positive charge on oxygen. Therefore, the bonded electron here will move into that oxygen, which means this group is going to be lost as water. So when it is lost, we now have H bond C bond O, H with a positive carbon here, with a positive carbon there. Now remember, there was a methoxide formed, deprotonated methanol. This methoxide will now come in and react with this species that has a positive center, positive carbon. This excess electron will now be migrated to this positive center, and we will finally have this. So when that new bond is established, we have this species. But looking at this species, one of the carbon atoms is still positive, having 3 bonds. So the lone pair, this proton, is going to be finally released as it leaves its bonded electron to this oxygen, and the bonded electron coming to re-establish the double bond. And that is when there will be deprotonation. Remember, this proton came from this acid, so it's going back to where it came from. And we now have this, the double bond O with O C H 3, and this is methyl methanoate. This is methyl group. This is methanoate group. So the name is methyl methanoate, and that is exactly this.